The three following gases, how are they similar? How are they different? This is going to require some drawing and some atomic fission. Oxygen gas, hydrogen gas, and water vapor. It felt kind of weird to say water gas, so just said water vapor right here. So inside these boxes, I'm going to try to draw some cartoon images of these gases. Okay, first the oxygen gas. Now oxygen gas has a formula of O2. So I'm going to draw two. These right here, this is meant to be one oxygen atom, just represented with a letter O, and another oxygen atom with a letter O right there. It's kind of spaced around here. This is trying to represent a gas because the molecules are far apart and they don't have a structure or order to them, not like a solid would or a crystalline solid. Now, because this is a static picture, I'm going to put some arrows in an attempt to show movement. And I've tried to draw these gases. They're moving in a bunch of random directions, and they move in a straight line unless they hit something or another molecule. Hydrogen gas. The formula for hydrogen gas is H2. So that is two hydrogen atoms bonded to each other. These little cartoon images here, I'm not trying to show protons, neutrons, or electrons or the number of bonds. I'm really just showing the number of elements that are present and trying to put some of that gas action going on in there. When I say gas action, let's have some colliding. So when they collide, one's going to bounce off. They're going to deflect off each other right there. So kind of imagine these as like pool balls, cue balls bouncing around the pool table after a break. This static two-dimensional image is not very good. You need your imagination. You need to imagine the movement of the molecules moving and bouncing around like bees or billiard balls. You need to imagine the third dimension. This is, shall we say, one slice of bread in a loaf. So imagine an infinity amount of loaves of slices of bread stacked above with, again, molecules just colliding around right there. Water vapor. Now water, and again, these are both images of gases because they're far apart. The molecules are far apart from one another. They're moving very fast. And they're not ordered or structured or related to each other. H2O. So this, I'm going to try, again, this is, again, a simple structure, a simple way to try to note the order or arrangements. Here we see a gas molecule that's composed of two different elements, a 2-to-1 ratio of hydrogen to oxygen, the H dose O. And I'm going to draw a couple of these in here. I'm drawing just 4 or 5, just for not for no particular reason. I'm only just drawing a couple right there. Again, because they're gas water molecules bouncing around that are not ordered, that are moving very quickly, and that are far apart from each other. I'm going to draw some arrows to try to show the viewer some of that kinetic moment right there. Thank you.